Have you ever just stopped and wondered about the absolute magic that lets your phone, your laptop, and some server halfway across the world all speak the same language? It seems kind of impossible, right? But it's happening all the time, and it's all thanks to a shared rulebook for computers.
No, seriously, think about that for a second. You've got an iPhone running iOS and maybe a custom-built gaming PC running Windows. They are completely different beasts built by different companies with totally different software. So how on earth do they manage to connect and swap information without a single hiccup? Well, the answer is surprisingly elegant.
It all comes down to a brilliant idea called layering. See, instead of trying to solve one single, gigantic, mind-bendingly complex problem, we chop it up into a bunch of smaller, much more manageable pieces. Each layer has exactly one job to do, and it focuses on doing that one job perfectly, without having to worry about what the other layers are up to.
And this whole strategy gets formalized in what is basically a universal rulebook for computers. It's called the Open Systems Interconnection Model, or as everyone calls it, the OSI model. You can think of it as the universal translator that lets any device talk to any other device, no matter who made it or what software it's running.
So, we've got this universal set of rules. But what's the big picture? What was the ultimate goal of this model? What problem was it really trying to solve?
The whole point, and this is the real game changer, was to let any two systems in the world talk to each other without needing to change their core hardware or software. It's a set of guidelines that creates universal compatibility, making sure that a message sent from my computer can be understood by your computer, period.
Okay, so this model is built on layers. Specifically, it breaks down the entire complex process of network communication into a 7-layer journey, and every single piece of data has to take this trip. Now, before I show you the layers, you're probably thinking, 7 layers? How am I going to remember all that? Well, I've got the secret for you. Just remember this silly sentence. Please do not throw sausage pizza away. I know, it sounds ridiculous, but trust me on this, it's the best way you'll ever find to memorize these.
And here they are, the 7 layers of our journey. Our little phrase, please do not throw sausage pizza away, maps perfectly. Up at the top, we have layer 7, please, for application. This is the layer you actually see and touch, your web browser, your email app. Then we have do not, that's layers 6 and 5, presentation and session. They're the behind-the-scenes crew, handling stuff like data formatting, encryption, and just managing the connection. Layer 4, throw, for transport, is kind of like the postal service. It decides how the data gets sent and if we need a delivery receipt. And the bottom 3, our sausage pizza away, are the real delivery drivers, network, data link, and physical. They handle everything from the global IP address and the local network address, all the way down to the actual wires and Wi-Fi signals.
What's really cool is the symmetry of this whole process. On the computer that's sending the data, your message starts at the very top, at layer 7, and it travels down the stack. At each layer, it gets wrapped in a little bit of new information. It's like putting a letter in an envelope, then putting that envelope in a small box, and then that box into a bigger one. On the other end, the receiving computer does the exact same thing, but in reverse. The data arrives at the bottom layer and travels up, getting unwrapped at each step until it's back to its original, readable form.
And here's the one golden rule that keeps this whole thing from becoming total chaos. A layer can only talk to the layers that are right next to it. So the transport layer, for example, only talks to the session layer above it and the network layer below it. That's it. No skipping steps. It keeps the process clean, orderly, and reliable.
But here's a little twist. The journey your data takes from your computer to another one isn't a direct flight. It has to pass through a few checkpoints along the way. Think of them like traffic hubs. Right. These intermediary devices, we call them routers, are basically the traffic cops of the internet. Their job isn't to open up your package and read the contents. Their job is just to look at the address on the box and figure out the fastest way to get it to its destination. And to do that, they only need to look at a few specific layers.
In fact, out of all 7 of those layers we just walked through, these incredibly powerful and important devices only need to care about the information packed into 3 of them, just 3.
And the 3 layers a router cares about are the bottom 3. It needs the network layer to read the final destination, the global IP address. It needs the data link layer to figure out the very next hop on the local network. And of course, it needs the physical layer to handle the actual cables and signals. That's all the info it needs to make a decision and send your data on its way. And this design is, frankly, brilliant. It's super efficient because the router doesn't waste time and processing power unwrapping all 7 layers. But more importantly, it's secure. It means the router never even looks at your actual data. The email you wrote,
the website you're on, that stuff lives way up in the application layer, completely invisible and untouched.
So, after all that, let's zoom out. Why does this theoretical model, something designed decades ago, still matter so much? What's the big takeaway here?
It's because this 7-step dance, this whole process of packaging and unpackaging data as it flies up and down the stack, is the invisible engine that runs our entire digital world. Every email you send, every video you stream, every single thing you do online is following these exact rules, silently, in the background.
The OSI model is the essential blueprint for how all networks should work. It's the perfect architectural plan. Which, leaves us with one last really fascinating question to think about. If this model is the perfect blueprint, what did we end up actually building in the real world? But hey, that's a story for another time. Thanks for joining.